Welcome dear students. Now we can think about the next intermediate, and that is nothing but carbanion. So what are carbanions? Carbanions are organic ions contain what? A negatively charged carbon. Organic ions contain a negatively charged carbon. Okay. So negatively charged carbon. Okay. Or we can have the definition organic species, is it? Organic species which contain a negative charge carbon. So anyway, carbon with a minus charge, that is what is called carbanion. And we have some examples like as we have discussed in the case of carbocation, is it CH3 plus. Similarly we have CH3 minus, CH3, CH2 minus, is it? Then what is this group? CH3 twice CH isopropyl, is it? CH3 twice CH minus, like that. So these are alkyl carbanions like methyl carbanion, is it? Ethyl carbanion, isopropyl carbanion, tertiary butyl carbanion, like that. So we have examples like alkyl carbanions. And next we can think about the preparation. How these carbanions are prepared? In the case of carbocations, we have discussed the heterolysis method. Similarly, heterolysis can also be used here. Heterolysis is used for the production of carbanions because you know that heterolytic bond fission leads to the formation of anions and cations. So here also you can have heterolysis, but here you should remember that in the case of carbocation, just I am refreshing, carbocation carbon is connected to X. X means halogen or electronegative. For generating carbocation, cation in the previous case, for generating carbocation we are using, or carbon is connected to more electronegative atom. Carbon is connected to more electronegative like halogen, is it? But here in the case of for the formation of carbanion, what? You should remember that carbon atom is connected to, let it be Z. What is Z? Z is less electronegative than carbon. Z should be less electronegative than carbon. So when carbon atom is attached to a less electronegative atom, that heterolysis leads to the formation of, when heterolysis takes place, what? Actually when it is less electronegative, it leaves, is it? It gives up the 2 electrons to the carbon atom. Whenever the leaving group migrates without electron, then only carbanion is generated, is it? And we can have hydrogen as a simple example. In the case of, we can replace this Z by hydrogen, is it? When we have hydrogen atom, you know that even though both are little bit same electronegativity, with carbon and hydrogen have almost same electronegativity. Here the point is that if you are using a base, please remember, if you are using a base, what is the role of a base? Base will accept proton, is it? You know that base will accept proton. So as a result, if you are using a base, actually this H plus is released and you will have this C minus, and this base will accept this proton, or BH is formed. Okay, you can simply write BH. Okay, or you can have a specific example like RH. So for heterolysis you can write like this: RH gives what? In presence of a base, RH gives R minus plus BH. Okay, and this is the method for preparation. Simple method, heterolysis, you can remember easily. And it is very important that whenever this carbanion is formed, when it is stable, then only it will exist. For example, if you are having this CH3NO2, from this you can, how we can generate a carbanion? Methyl nitrate, that is given in your textbook. So if you are using a base, okay, So if you are using a base, that base will accept proton. And what is the generation? What is the formation of when CH3NO2? CH3NO2 will no H plus boy you will get CH2 minus NO2. Okay, and you know that what this NO2 is unsaturated. So whenever a carbanion is formed and when it is stabilized by resonance, delocalization of charge will give stability. So CH2 double bond, what, N, is it? CH2 double bond N, O minus, coordinate bond. Okay, so this is also as a method you can write. So this is carbanion. Okay, and this carbanion is stable. Stability is also given here. This is stable by resonance. Okay, or any of these two reaction, any one reaction you can given as an example for preparation. So at least from ethyl nitrate or from RH simply you can have. Okay, so this is preparation. Then next we have structure. Structure means hybridization. Mainly we are explaining the hybridization of carbon atom. In carbanion, what is hybridization? So if you are thinking about the structure of a carbanion, we can focus on 2 points. Generally, if you are having an alkyl carbanion as methyl, ethyl, isopropyl like that, CH3 minus, okay, alkyl carbanion, the hybridization is sp3. Okay, so when we are thinking about an alkyl carbanion, methyl or ethyl carbanion, the central carbon atom undergoes sp3 hybridization. Okay, and if it is sp3 hybridization, this is the shape. What will be the shape? This is like a pyramidal shape. Okay, and you know that the shape is pyramidal. Okay, and like that of ammonia, amines, is it? Amines, we have pyramidal shape with one lone pair. So shape will be pyramidal and hybridization will be sp3. And generally this is the case of alkyl carbanion. But in some cases, when this carbanion, when it is attached to what? When it is attached to an unsaturated system. When it is attached to an unsaturated system like this benzyl carbanion. Okay, when this carbanion is attached to an unsaturated system. Actually, when we are thinking about this compound, benzene as such, is it? Is not unsaturated because there is delocalization. But when it is connected to a double bond, simply you understand that when CH2 minus is connected to a double bond, sometimes the hybridization is taken as sp2. Okay, so it is better to remember in the case of alkyl carbanion with the sp3 hybridization, that is given in your textbook. But sometimes നിങ്ങൾ എവിടെയെങ്കിലും വായിക്കുവാണെങ്കിൽ നിങ്ങൾക്ക് തോന്നുവാണെങ്കിൽ എന്താ അൺസാച്ചുറേറ്റഡിലേക്ക് കണക്ട് ചെയ്യുവാണെങ്കിൽ ഹൈബ്രിഡൈസേഷൻ ഈസ് ഗിവൺ ലൈക്ക് sp2 എന്നും പറയുന്നുണ്ട്. ഓക്കെ, ഇഫ് ഇറ്റ് ഈസ് sp2 ഷേപ്പ് വിൽ ബി ലൈക്ക് ദിസ് അല്ലേ, നമ്മൾ നേരത്തെ കാർബോ കാറ്റോണിക് കണ്ട പോലെ അൺഹൈബ്രിഡൈസ്ഡ് പ്യുവർ അൺഹൈബ്രിഡൈസ്ഡ് പി ഓർബിറ്റലിലായിരിക്കും 2 ഇലക്ട്രോൺസ്. ഓക്കെ, അങ്ങനെ ഒരു ഷേപ്പും കൂടെ ഉണ്ട്. ബട്ട് നിങ്ങൾ ടെക്സ്റ്റ് പറഞ്ഞിരിക്കുന്ന പോലെ sp3 അതിൻ്റെ ഷേപ്പ് വരച്ചാൽ മതി. ഓക്കെ, pyramidal shape and structure is like this. That is enough. Okay, so when we are explaining the structure, you just simply give the structure as figure, is it? Figure as well as hybridization and shape. Okay, then we can think about the stability. Stability means what? Stability of carbanion is usually by delocalization of charge. So as we have seen in the case of carbocation, is it? Benzyl carbocation nammalokku undarunnu. Similarly, benzyl carbanion also you can write. Then what? In the case of benzyl carbanion, this negative charge can delocalized. Okay, so in benzyl carbanion you can draw the resonating structures like this. Okay, so when it is CH2, it becomes double bond, then a minus charge here, is it? Then what? You can write the next structure like this. Okay, negative charge here, double bond here, double bond here, double bond CH2. Then similarly you can have next structure, is it? Double bond CH2. Okay, so 1, 2, 3 and 4 structures are there. നമുക്ക് ഒരു സ്ട്രക്ചർ വരയ്ക്കാമെന്ന് തോന്നും, പക്ഷേ ഇനി വരച്ചാൽ കിട്ടുന്നത് എന്തായിരിക്കും? ഫസ്റ്റ് സ്ട്രക്ചർ തന്നെ ആയിരിക്കും കേട്ടോ. സോ 4 structures are there, similar to carbocation നമ്മൾ ചെയ്ത പോലെ തന്നെ. So we can say that benzyl carbanions are more stable. Benzyl carbanions are stable than alkyl carbanions. Is it? Because in alkyl carbanion there is no mesomeric effect. So this is stability due to mesomeric effect or resonance effect. Resonance or mesomeric. നമ്മളിപ്പോൾ കാണിച്ചിരിക്കുന്നതാണ് resonating structures അല്ലേ? So mesomeric effect or resonance effect. So that is operating in benzyl carbocation, and benzyl carbocations are more stable than alkyl carbocations. So similarly നമ്മൾ ഇന്നലെ കഴിഞ്ഞ ദിവസം കണ്ട പോലെ allyl എഴുതാം അല്ലേ? CH2 double bond CH2 minus. allyl also you can write അല്ലേ? നിങ്ങൾക്ക് ഈസി ആയിട്ട് എഴുതാം. നെഗറ്റീവ് ചാർജ് ആണ്. അല്ലൈലിൻ്റെ കേസിൽ ഒരു പ്രശ്നമുണ്ട്. നെഗറ്റീവ് ചാർജ് there is only one structure, is it? So there is no need to write allyl. Okay, allyl കാണിച്ചില്ലെങ്കിലും കുഴപ്പമില്ല, because only 3 carbon atoms are there. Okay, so allyl വേണ്ട. benzyl is enough. Okay, ഒരു കാർബണും കൂടെ വന്നാലേ നമുക്ക് സ്ട്രക്ചർ കാണിക്കാൻ പറ്റുള്ളൂ, is it? So benzyl carbanions are stable than alkyl carbanions. Yeah, allyl also you can write, no problem. നമ്മളത് കാണിച്ചതിൻ്റെ പ്രശ്നമായിരുന്നു. അല്ലൈലിൻ്റെ സ്ട്രക്ചർ എങ്ങനെ വരുന്നു നോക്കിയേ? CH2 ഡബിൾ ബോണ്ട് CH2 മൈനസ് അല്ലേ? ഇത് മതി. allyl carbanion. How will you write the resonating structure? Like this you can represent, no problem. നിങ്ങൾക്ക് എളുപ്പമുള്ളതായതുകൊണ്ട്, ബിക്കോസ് ഇതേ ഓൾറെഡി നമ്മൾ കാർബാനിയോൺസിൽ പഠിച്ചതാണല്ലോ. ഓക്കെ, സോ നിങ്ങൾ ടെക്സ്റ്റിലെ എല്ലാ എക്സാമ്പിളും കാണിക്കണമെന്നില്ല, ഇങ്ങനെ ഏതെങ്കിലും എളുപ്പമുള്ള ഒന്നെണ്ണം കാണിച്ചാൽ മതി. സോ allyl and benzyl are stable. Okay, then regarding stability of alkyl carbanions, നമ്മൾ കാർബോകാറ്റോൺസ് എങ്ങനെയായിരുന്നു? കാർബോകാറ്റോൺസിൻ്റെ സ്റ്റെബിലിറ്റി പറഞ്ഞപ്പം tertiary greater than secondary greater than primary, because electron releasing inductive effect കൂടുതലാകും തോറും സ്റ്റെബിലിറ്റി കൂടും അല്ലേ? ആ രീതിയിൽ. ബട്ട് ഹിയർ whenever the electron releasing groups, whenever the number of electron releasing groups increases, stability decreases. Okay, stabilization of alkyl carbanions in the stability എന്ന് പറയുമ്പോൾ stability explanation is by inductive effect and hyperconjugation നമ്മൾ ഇന്നലെ പറഞ്ഞായിരുന്നു. And here നമ്മളിവിടെ inductive effect, stability is explained by inductive effect. Okay, so stabilization of carbanions by inductive effect is in opposite direction from carbocation. Therefore that means electron releasing groups, നമ്മൾ പഠിക്കും, electron releasing group decreases the stability. So what about the stability order of carbanion? Carbanion stability order is primary greater than secondary greater than tertiary. Okay, നമ്മൾ ഇന്നലെ കാർബോകാറ്റോൺസ് പറഞ്ഞപ്പോൾ tertiary greater than secondary greater than primary ആയിരുന്നു. But for carbanion it is primary greater than secondary greater than tertiary, or we can write RCH2 minus അല്ലേ? RCH2 minus, which will be more stable than R2CH minus, which is more stable than R3C minus. Okay, so that's about the stability. If you have studied carbocation, like you can compare carbocations and carbanions. Preparation is same, heterolysis, but നമ്മൾ halogens-ന്റെ കേസിൽ you are using hydrogen, is it? So heterolysis is there for preparation. Then structure, sp3 hybridization, pyramidal in shape, is it? Structure also you have to draw. Then sometimes when carbon is connected to unsaturated groups, sp2 also possible. Then what? Stability of benzyl is greater, allyl also greater, but benzyl is more stable, and primary is stable than secondary than tertiary. And another thing is that when we have some groups, yeah, that is also important. When we have some groups like when this carbanion is connected to, and that type of examples are given in your textbook. When the carbanion is connected to an unsaturated functional group, like what? A lot of examples are given in your textbook. When CH3CHO, acetaldehyde, is it? So when acetaldehyde, when it is reacting with a base, നമ്മൾ ആദ്യം കണ്ട പോലെ എന്തായിരുന്നു, ഒരു ബേസിൻ്റെ കൂടെ ചെയ്യുമ്പോൾ you will get CH2 minus COH, is it? And this is stabilized whenever a carbanion or negative charge is near to oxygen atom, or sorry, double bond, unsaturated functional group, this shift is possible, is it? As a result, what? CH2 double bond CO minus H will be formed. Okay, so one or two examples are given, nothing but as we have seen in the case of allyl, like that. So an unsaturated functional group is connected to carbon, or it may be like NO2, നമ്മൾ NO2 example കണ്ടായിരുന്നു, or esters also same example. Okay, that type of example also you can given for stability. So that much about carbanion preparation, structure and stability. Thank you.